All right, and what's up, man? Another exciting opportunity to just jump back into this. So now we're jumping into chapter 1 of Eloquent JavaScript. Read along. We're going to be reading along this project today. Start by a quote. Below the surface of the machine, the program moves without effort. It expands and contracts in great harmony. Electrons scatter and regroup. The forms on the monitor are but ripples on the water. The essence stays invincibly below. This is by Master Yuan Ma from the Book of Programming. And I think these are the ripples on the screen. I like that image. And then, yeah, I think so. These are the electrons that scatter and regroup. Cool. All right. So inside the computer's world is only data. You can read data, modify data, create new data, but that which isn't data cannot be mentioned. That is a computer's world. All this data is stored as long sequences of bits and thus fundamentally alike. Data looks alike. Bits are any kind of two-valued things, usually described as zeros and ones. Inside the computer, they take forms such as high or low electrical charge, a strong or weak signal, or shiny or a dull spot on the surface of a CD. Any piece of discrete information can be reduced to a sequence of zeros and ones and thus represented in bits. Discrete information, and that's discrete math. So for example, we can express the number 13 in bits. It works the same way as a decimal number, but instead of 10 different digits, you only have 2. And the weight of each increases by a factor of 2 from right to left. It by a factor of 2. Okay, so 2, 4, alright, I get it. Here are bits that make up the number 13 and the weight of the digits below them. So, and the weight increased by a factor of 2. Okay, fine. So if this is 1, this becomes 2, and then 4, 8, 16, 32, 64, and 128. So that's the binary number is 00001101. Its non-zero digit stands for 8, 4, and 1. Non-zero digits 1, 8, 4, and 1. That add up to 13. Oh, I get it. So this is 1 plus 4, 5, 5 plus 8, that's 13. Imagine a sea of bits in an ocean of them. A typical modern computer has more than 30 billion bits in its volatile data storage, that's the working memory. Non-volatile storage, that's the hard disk equivalent, tends to have yet a few orders of magnitude more. To be able to work with such quantities of bits without getting lost, we must separate them into chunks that represent pieces of information. In a JavaScript environment, those chunks are called values. I guess you could also say in a C or Python environment or whatever, but in a C environment, the chunks of information are called values. Though all values are made up of bits, they play different roles, and every value has a type that determines its role. Some values are numbers, some values are pieces of text, some values are functions, and so on. To create a value, you must merely invoke its name. Value. This is convenient. You don't have to gather building material for your values or pay for them. You just call for one and whoosh, you have it. They are not really created from thin air, of course. Every value has to be stored somewhere, and if you want to use a gigantic amount of them at the same time, you might run out of memory. Fortunately, this is a problem only if you need them all simultaneously. As soon as you no longer use a value, it will dissipate, leaving behind its bits to be recycled as building materials for the next generation of values. Wow, okay. This chapter introduces the atomic element of JavaScript program and is the simple value types and the operators that can act as such values. Numbers. The value of number type are unsurprisingly numeric values. In a JavaScript program, they are written as follows: 1, 3. Use that in a program and it will cause a bit of a and it caused the bit pattern for the number 13 to come into existence inside the computer's memory. JavaScript uses a fixed number of bits, 64 of them, to store a single number value. There are only so many patterns you can make with 64 bits, which means that the number of the different numbers that can be represented is limited. The number of the different numbers. With n decimal digits, you can represent 10 to the nth numbers. Similarly, given 64 binary digits, you can only represent 2 to 64 different numbers, which is about 18 quintillion. That's an 18 with 18 zeros after it. And that's a lot. That's a lot. So computer memory used to be much smaller, and people tended to use groups of 8 or 16 bits to represent their numbers. It was easy to accidentally overflow such small numbers to end up with a number that did not fit into a given number of bits. Today, even computers that fit into your pocket have plenty of memory, so you are free to use 64-bit chunks, and you need not worry about overflow only when dealing with truly astronomical numbers. Not all whole numbers less than 18 quintillion fit in a JavaScript number though. Those bits also store negative numbers, so one bit indicates the sign of the number. Alright. A bigger issue is that of a non-whole number must also be represented. To do this, some of the bits are used to store the position of the decimal point. The actual maximum whole number that can be stored is more in the range of 9 quadrillion, that's 15 zeros, which is still pleasantly huge. Fractional numbers are written using a dot, so that's 9.81. And for every big or small number, you may also use scientific notation by adding an e for exponent followed by the exponent of the number. For example, that is a 2.998 E8. That is 2.998 raised to 10 times 10 raised to 8. That's the exponent. Calculations with whole numbers, also called integers, smaller than the aforementioned 9 quadrillion, are guaranteed to always be precise. Unfortunately, calculations with fractional numbers are generally not. Just as pi cannot be precisely expressed by a finite number of decimal digits, many numbers lose some precision when only 64 bits are available to store them. This is a shame, but it causes practical problems only in specific situations. The important thing is to be aware of it and treat fractional digital numbers as approximations and not as precise values. Arithmetic. The main thing to do with numbers is arithmetic. Arithmetic operations such as addition or multiplication take two number values and produce a new number from them. Here's what they look like in JavaScript. 100 plus 4 times 11, or asterisk 11. The plus and asterisk symbols are called operators. These are called operators. The first stands for addition and the second stands for multiplication. Putting an operator between values will apply it to those values and produce a new value. But does the example add 4 and 100 and multiply the result by 11, or the multiplication is done before adding? As you might have guessed, the multiplication happens fast. But as in mathematics, you can change this by wrapping the addition in parentheses. So it will follow the math principle, but you can change this by wrapping addition in parentheses. For subtraction, there's the minus operator. The division can be done with the forward slash operator. When operators appear together without parentheses, the order in which they are applied is determined by the precedence of the operators. The example shows that multiplication comes before addition. The / operator has the same precedence as the asterisk. Likewise for plus and minus. When multiple operators have the same precedence appear next to each other, as in 1 minus 2 plus 1, they are applied left to right. That is 1 minus 2 minus 1 plus 1. Alright. These rules of precedence are not something you should worry about. When in doubt, just add parentheses. There is one more arithmetic operator which you might not immediately recognize, and that is the percent symbol. It's used to represent the remainder operation. So x remainder y is the remainder of dividing x by y. For example, 314 remainder 100 produces 14. So as 100, it will be 100 goes into 314 3 times rem 14. So that is, I get it. And 144 divided remainder 12 gives 0 because 12 goes into 144. 12 times no remainder. The remainder operator's precedence is the same as that of multiplication and division. You'll also often see this operator referred to as modulo, special numbers. There are 3 special values in JavaScript that are considered numbers but don't behave like normal numbers. The first 2 are infinity and negative infinity, which represent the positive and negative infinities. Infinity, -1, is still infinity, and so on. Don't put too much trust in infinity-based computation though. It's isn't mathematically sound and will quickly lead to the next special number, none, which is not a number. Yeah, none, N stands for not a number. Even though it is a value of the number type, you'll get this result when you, for example, try to calculate 0 by 0, or infinity minus infinity, or any number or other numeric operations that don't yield a meaningful result. We're going to get not a number. So now we've looked at numbers, we've looked at operators, and we're still at numbers, operators, and now we're still moving to to strings. The next basic data type is the string. String are used to represent text. They are written by enclosing their content in quotes. Down on the sea, lie on the ocean, float on the ocean. You can use single quotes, double quotes, or backticks to mark strings, as long as the quotes at the start and at the end of the string match. Almost anything can be put between quotes. And in JavaScript, we'll make a string value out of it, and JavaScript will make a string value out of it. But a few characters are more difficult. You can imagine how putting quotes between quotes can be hard. New lines, that's the character you get when you press enter, can be included without escaping only when the string is quoted with a backtick. To make it possible to include such characters in a string, the following notation is used. Whenever a backslash is found inside a quoted text, it indicates that the character after it has a special meaning. This is called escaping the character. A quote that is preceded by a backslash will not end a string but be a part of it. When an N character occurs after a backslash, it is interpreted as a new line. Similarly, a T after a backslash means a tab character take the following string. This is the first line, \n, and this is the second. The actual text contained looks like this. This is the first line and this is the second. There are of course situations where you want a backslash in a string to be just a backslash, not a special code. If two backslashes follow each other, they will collapse together and only one will be left in the resulting string value. This is how the string a new line character is written like. Open quote, a new line character is written like open quote \n can be expressed. So it will be written in code as a new line character is written like backslash open quote backslash n backslash quote full stop close quote. Very cool. To make it a string. Strings too have to be modeled as a series of bits to be able to exist inside the computer. The way JavaScript does this is based on a Unicode standard. This standard assigns a number to virtually every character you would ever read, including characters from Greek, Arabic, Japanese, Armenian, and so on. If we have a number for every character, a string can be described by a sequence of numbers. And that's what JavaScript does. But there's a complication. JavaScript's representation uses 16 bits string element, which can describe up to 2 raised to 16 different characters. But Unicode defines more characters than that, about twice as many. About twice as many at this point. So some characters, such as mini emoji, take up 2 character positions. In JavaScript strings, we'll come back to this in chapter 5. Strings cannot be divided, multiplied, or subtracted, but the plus operator can be used on them. It does not add, but it concatenates. It glues strings together. The following line will produce the string concatenate. It's string con plus string cat plus string a plus string net, concatenate. String values have numbers of associated functions, which are methods that can be used to perform other operations on them. I'll tell you more about this in chapter 4. Strings written with single or double quotes behave very much the same. The only difference is which type of quote you need to escape inside of them. Backtick quoted strings usually have template literals and can do few more tricks. Apart from being able to span lines, they are also embedded in other values. Half of 100 is, I think that's a template literal. 100 over 2. When you see something like dollar curly braces in a template literal, its results will be computed, converted to a string, and included in that position. The example produces half of 100 is 50. So yeah. Unary operators. Not all operators are symbols. Some are written as words. One example is the type of operator. So here we're still talking about operators, and we also have the unary operator. So I think we can say we have what are these types of operators? How do we call them? These ones in arithmetic, do they have a name or they're just operators? They're just called operators. Okay, fine. So unary operators. So not all operators are symbols, some are written as words. One example is the type of operator, which produces a string value naming the type of the value you give it. So console log type of 4.5. should output the number, and then console log the type of open quote x open, so it will output the string x. Interesting. We use console log in example code to indicate what we want to see. Console.log. Let me use console.log. We use console.log in example code to indicate that we want to see the result of evaluating something. More about that in the next chapter. The other operators shown all operated on two values, but type of takes only one. Operators that use two values are called binary operators, and those that take one are called unary operators. The minus operator can be used both as a binary operator and as a unary operator. And so that is here we're saying console.log open brackets minus 10 minus 2. And then the answer will be minus 8. And then now we go to Boolean values. It is often useful to have a value that distinguishes between only two possibilities like yes and no, or on and off. So for this purpose, JavaScript has a Boolean type, which are just two values, true and false, which are written as these words, as those words, true equals true, equals false. Here's one of the way to produce a Boolean value. Console.log 3 is greater than 2. What will it print? Let's try it. Let's delete it and tell it console.log 3 is greater than 2. And let's see. Let's look at the console. It should tell us true. It is true. All right. And then console log true 3 is less than 2 is false. The greater and lower, greater than and lower than sign are traditional symbols for is greater than and is less than respectively. They are binary operators. Binary operators. Applying them results in a Boolean value that indicates whether they hold true in this case. String can be compared the same way. Console.log string advark is less than Zoroaster, which is true. The way strings are ordered is roughly alphabetic, but not really what you'd expect to see in a dictionary. Uppercase letters are always less than lowercase ones, so Z is less than A. And non-alphabetic characters, that is exclamation mark, dash, and so on, are also included in the ordering. When comparing strings, JavaScript goes over the characters from left to right, comparing the Unicode codes one by one. Alright. Other similar operators are, greater than or equal to, and then less than or equal to, and then equal to, and not equal to, which is exclamation mark equals, not equal to. So console log Ichi is not equal to scratching. True. Console log apple is equal to orange, which is false. There's only one value in JavaScript that is not equal to itself, and that is not a number. So console log not a number is equals to not a number, that is false. Not a number is supposed to denote the results of an nonsensical computation, and as such, it isn't equal to the result of any other nonsensical computation. Now we go to logical operators. We've looked at binary operators. Now we're looking at logical operators. There are also some operators that can be applied to Boolean values themselves. JavaScript supports three logical operators, and, or, and. not. This can be called reason. It can be used to reason about booleans. The ampersand ampersand operator represent the logical AND. It is the binary operator that results in true only if both values are given to it are true. So console log true ampersand ampersand false. The answer is false because it's supposed to be true ampersand ampersand false, supposed to be true false. Console log true ampersand ampersand true is true. The I don't know what to call that key. Denote the logical OR. So it produces true either if the values given to it is true. So console log false or true. That's true. Console log false or false. Not is written as an exclamation mark, and it is a unary operator that flips the value given to it. Exclamation mark true produces false, and false gives true. When mixing these Boolean operators with arithmetic and other operators, it is not always obvious when parentheses are needed. In practice, you can usually get by with knowing that the operators we have seen so far, this OR, has the lowest precedence, and then comes the AND, and then the comparison operators, which is greater than, equals to, and so on. And then the rest. This order has been chosen such that in a typical expression like the following one, a few parentheses are as possible and necessary. And the last logical operator I will discuss is not unary, not binary, but ternary. So we talked about unary, we talked about binary, we even talked about logical operators, and now we're talking about ternary operators. Operating on three values, and it is written with a question mark and a colon, like this: console log true question mark 1 to 2, which is 1, and console log false question mark 1 to 2 is false, is 2. This one is called the conditional operator. This one is called the conditional operator, or sometimes just the ternary operator, since it is the only such operator in the language. The value on the left of the question mark picks which one of the two will come out. When it's true, it chooses the middle value. When it is false, it chooses the value on the right. And then empty values. There are two special values written as null and undefined. They are used to denote the absence of a meaningful value, and they are themselves values, but they carry no information. Many operations in the language that do not produce a meaningful value, you'll see some later, yield undefined, simply because they have to yield some value. The difference in meaning between undefined and null is an accident of the JavaScript design, and it doesn't matter most of the time. In cases where you actually have to concern yourself with these values, I recommend treating them as mostly interchangeable. Then automatic type conversion. In the introduction, I meant that JavaScript goes out of its way to accept almost any program that you give it, even programs that do odd things. This is nicely demonstrated by the following expression. Console.log, open brackets, 8 multiplied by null. It gives you 0. Console.log 5, which is a string. So I think on the first one, 8 multiplied by null is supposed to provide null, I guess. If this is what we read here, it means nothing, but I think JavaScript decides for you. Maybe you meant 0. And then when you say console.log 5 the string minus 1, might decide maybe you forgot this is the string, so I'm just going to minus it. When we say console log 5 as a string plus 1, it concatenates, assumes this is also a string, it's going to make it 1. Console.log 5 as a string multiplied by 2, it will give you not a number. And then console.log false is equal to 0, it will tell you yes, true. When an operator is applied to the wrong type of value, JavaScript will quietly convert that value to the type it needs using a set of rules that often aren't what you want or expect. This is called type coercion. It coerces your type. The null in the first expression becomes 0, and the string 5 in the second expression becomes 5 from string to number. Yet in the third expression, plus tries concatenation before numeric addition. So the 1 is converted to one string from number to string. When something that doesn't map to a number in an obvious way, just a 5 or undefined, is converted to a number, you get the value not a number. Further arithmetic operations on not a number keep producing not a number. So if you find yourself getting into one of those unexpected places, look for accidental type conversions. When your code starts breaking and you can't understand why it was breaking, look for unexpected accidental type conversions. When comparing values of the same type using equals, the outcome is easy to predict. You should get true when both values are the same. Expect in the case of not a number. But when the types differ, JavaScript uses a complicated and confusing set of rules to determine what to do. In most cases, it just tries to convert one of the values to the other values type. However, when null or undefined occurs on either side of the operator, it produces true only if both sides of one are one of null or undefined. So, for example, console.log null is equal to undefined, that is true. Console.log null is equal to 0, that is false. That behavior is often useful when you want to test whether a value has real value instead of null or undefined. You can compare it to the null with the equal or not operator, which is exclamation mark equal. But what if you want to test whether something refers to the precise value false? Expressions like 0 is equals to false and string is equals to false are also true because of the automatic type conversion. When you do not want any type of conversions to happen, there are additional operators. For example, equals and not equals. The first tests whether the value is precisely equal to the other, and the second tests whether it is precisely not precisely equal. So string equals false is false as expected. It doesn't break. It doesn't allow JavaScript to do that weird thing it does. I recommend using 3-character comparison operators defensively to prevent unexpected type conversions from tripping you up. But when you are certain that the types on both sides will be the same, there's no problem with using the short operators. Short-circuiting of logical operators. The logical operators ampersand, and whatever that slash key is called, we think it was called logical and logical or, handle different types in a peculiar way. They will convert the value on the left side to a Boolean type in order to decide what to do. But depending on the operator of the result of that conversion, they will return either the original left-hand value or the right-hand value. The logical OR operator, for example, will return the value to its left that can be converted to true, and will return the value on its right otherwise. This has the expected effect when it comes to the values are Boolean and does something analogous for values of other types. Let's read that again. I feel like I just went through that statement. The logical OR operator, for example, will return the value to its left when that can be converted to true, and will return the value on its right otherwise. So this has the expected effect when the values are Boolean and does something analogous for values of other types. So for example, in this example, when you say console.log null or user, it will give you user. When you say Agnes or user, it will give you Agnes. So yeah, or logical or. Okay. We can use this functionality as a way to fall back on a default value. If you have a value that might be empty, you can put or after it with a replacement value. If the initial value can be converted to false, you'll get the replacement instead. The rules for converting strings and numbers to Boolean values state that 0, not a number, and the empty string count as false. Right? That is a simple tip for you guys. The 0 rules for converting strings to numbers to Boolean values state that 0, not a number, and empty strings count as false, while other yield value counts as true. So 0 or -1 produces -1, and empty string or open string exclamation mark question mark yields exclamation mark question mark. The logical AND operator works similarly, but the other way around. When the value to its left is something that converts to false, it returns that value, and otherwise it returns the value on the right. The AND operator works the similar way, but the other way around. When the value to its left is something that converts to false, it returns that value, and otherwise it returns the value to its right. Another important property of these two operators is that the part to their right is evaluated only when necessary. In the case of true or x, no matter what x is, even if it's a piece of program that does something terrible, the result will be true. And x is never evaluated. The same goes for false and x, which is false and will ignore x. This is called the short circuit evaluation. So the conditional operator works in a similar way. And the second and third values, only one that is selected is evaluated. Summary. We looked at 4 types of JavaScript values in this chapter. That was numbers, strings, booleans, and 9 identified values. Such values are created by typing the name, true, null, or value, for example 13 or ABC. And you can combine and transform values with operators. We saw a binary operators for arithmetic, that is plus, minus, forward slash, and what is exclamation point? What is it? Forget so quickly. Why you forget so quickly? Oh, it was a remainder. It was a remainder. Alright, and remainders. String concatenation with plus. Comparison with equals, not equals to, equals, 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 not equals, equals, less than, greater than, less than or equals to, greater than or equals to, and the logical and, logical or, as well as several unary operators are minus to negate a number, exclamation point to negate logically, and type of to find the values type, and the ternary operator to pick one of two values based on a third value. This gives you enough information to use JavaScript as a pocket calculator, but not much more. In the next chapter, we will start tying these expressions together into basic programs. That was so much fun, and I'm just gonna get this summary, and I'm gonna add here in my lesson 2, and I'm going to paste it, and that would be dope. Alright, so that's that. So you're going to stop this chapter and go to chapter 3.